the set of all possible outcomes for an event it is usually a diagram, picture, or table showing all possible outcomes. Okay. Example 1. How many possible outcomes are there if you flip a coin and then toss a die? A die is singular. Dice is when you have two of them. A die is singular, so there's one die. Yeah, so go to write example 1. So you define sample space. Put the example on the other side, by the way. Put this example 1 on the back side, it was blank. Because we're going to define the other words. So put example 1 in the back after you define sample space. So Soto, we crossed out the first 3 words and we're defining sample space. On the note, yeah, where it says, yeah, cross those puppies out. Oh, I got you.
Come on, man. Somebody can ask you.
What happened? No. Same one. Really? Hold up, I got you. All right, there you go. So here's sample space. The set of all possible outcomes. So I'm talking now? Simon, I'm talking? I got the floor here. The set of all possible outcomes, it's usually a diagram, picture, or table showing all possible outcomes. For instance, how many possible outcomes are there if you flip a coin and then toss a die? We're going to create a sample space. We're going to create a diagram. If I have a coin in my hand and one die, I flip it and then toss a die. How many possible outcomes are there in the end? Watch. So if I have a coin, there's 2 possible outcomes, right? Heads or tails. I flip the coin first. So after I flip the coin, I roll the die. How many possible outcomes are there on the die? 6. So from heads, go ahead and put 1, 2, 3, 4, 5, 6. And from the tails, go ahead and write like a tree, like a little tree diagram. 1, 2, 3, 4, 5, 6.
Hey, what are we doing here?
In the back. So this is all in the back here. Example 1's in the back of your paper. So you can fit it in there. So this is an example of a sample space. So if I flip a coin and then toss a die, how many possible outcomes are there? Well, let's see. If I flip the coin and toss a die, one possible outcome would be me flipping the coin, getting a heads, and then rolling a 1. So this outcome would have been a heads and then a 1. The second possible outcome is flipping the coin, getting a heads, and then rolling a 2. So this is the second one. Look at getting a heads and rolling a 2. This is getting a heads and then rolling a 3. This is getting a heads and rolling a 4. Heads rolling a 5. Heads rolling a 6. So look at, there's 6 possible outcomes of me flipping a coin and then rolling a die. 6 of them. And then the other 6 are if I roll a tails. So look here. Tails, 1. So that's as if I flipped the coin, I got a tails, and then I rolled the dice, got a 1. Tails, 2. I flipped the coin, got a tails. Roll the die, got a 2. You want to forget? Flip the coin, got a tails, then got a 3. So remember, this is a coin and a die. What are the possible outcomes here? Flip the coin, got a tails, then rolled a 4. Flip the coin, got a 5, or got a tails, and rolled a 5. Flip the coin, got a tails, and rolled a 6. So there's actually 12 possible outcomes here. Notice that. So here we go. So the question is, how many possible outcomes are there if you flip a coin and then toss a die? The answer is 12 possible outcomes. That's the answer. I was able to get 12 possible outcomes because I drew the sample space. I drew it out. Here's flipping a heads or tails, that's the coin. And then the second stage is actually rolling the die rather. Flipping the coin, then rolling the die. Okay. So example 2 underneath that on the back of your paper. Right, x2. Find, here we go, find the probability of rolling a tails and then getting a 5. Notice how I put capital P, that means a probability, and then in parentheses I describe what we're looking for in the event. I describe what we're looking for in the event. That's how you write probabilities. Okay. So what's the formula from this morning? The probability formula is, what goes on top? What's the name of the thing? Say again? I'll go on the bottom. We'll go on the top of it. So from this morning, the numerator is called favorable outcomes. Favorable means what's it you're looking for? Well, what do you want? Well, we want the tails and the 5. Out of the 12 outcomes, which one is a tail and a 5? How many of them? Only one. It's right here. So there's my numerator. And then, like Murillo said, the denominator is the total possible outcomes. That's 12, huh? So let's turn that into a decimal. 1 divided by 12. Let me get my calculator here. I'm going to go to Desmos real quick and get my calculator. He's this guy. It's this guy that gives me all the answers.
Tied?
No. 1 divided by 12. Let's look at 1 divided by 12. I'm going to round to the nearest hundredth place, the second decimal. So 0.08, this is a 3, so it's not 5 or bigger, so the 8's going to stay just 8. It's not going to go up to 9. So 0.08 will be my probability.
Isn't it 0.08?
0.08. You don't have to put the 0. You don't have to say the 0 when you pronounce it. So 0.08 is my probability as a decimal. So all I did is took 1 divided by 12, 0.08. We're rocking and rolling. How's it going? See, I'll be right here. I don't do that. Right here, right here. I don't fit. All right, that's example 2. Let's go ahead and define the next word here, which is, go ahead and cross out probability of an event because we already defined that this morning. We're going to define now theoretical probability versus experimental. So theoretical probability, here we go. Maybe the virus did hit, huh?
Did I bug you out of everything?
No. What's going on here? Here we go. All right, let's go back in there. So the next word is theoretical probability. Okay, theoretical probability. Here we go. Theoretical versus experimental. It's a huge idea that you need to grasp. My computer's acting strange.
Sputters.
Think so? Task manager. The snipping tool. Hang tight here.
Yeah, I did.
How about sandals?
It was like that type too on Oklahoma where you get these some light up ones.
I wasn't sketchy, but like to go run or something.
I'd rather wear some Nikes.
Yeah. I had a whole white guy out there. Or some Adidas.
Yeah.
All right, theoretical probability. My bad. I don't know what this computer is acting up today. Here we go. So theoretical probability. We're going to write this down now. Okay. So theoretical probability is number of favorable outcomes.
We run it exactly.
Exactly like this, right? Number of favorable outcomes. It's a fraction.
Really? You got the paper in here? Nothing.
Hat off, too.
Huh?
Hat off. Number of favorable outcomes over the number of total outcomes. So this is the one I just used a little while ago when I did the flipping of the coin and tossing the dice.
It's on the back.
Right. No, this is the front. Theoretical probability. So this is the word in the front. Favorable outcomes divided by the number of total outcomes. I just used this formula for the flipping of the coin and tossing of the die. Remember, phone's off right now. Earphones off for that second snap before break. Cross that one out because we already did that this morning. Cross out probability of an event. You're gonna watch the video later. Bet. Let's write this down. We'll talk about that later. Thanks, Noah. Number of successes divided by the number of trials is experimental probability. Here's what I mean by that. Say again?
Are we going to do trial and error stuff again?
Elaborate.
The trial and error, remember the assignment where it was also, I was asking for a new something like.
Let me chew on that. Hold on. So, example 2. So, go to flip your page. We're going to write example 3. Example 3. So, you're going to put example 3 on the other side. We've done example 1 and 2 on the other side. Here's example 3. Find the theoretical probability. I'll put P for probability of rolling a 6. Find the theoretical probability of rolling a 6. So this is on the other side, example 3. So what do I mean by this? You may have heard before, Soda, I got the floor here. You may have heard before the difference between theory and practice. Theory is something that we do in our mind. We imagine things going on, and we plan accordingly or do accordingly just based on our mind, what our mind is fabricating or our mind is manufacturing. So theoretical probability, I want you to think of this dice, just me looking at the dice and me actually not throwing the dice. Once I start throwing the dice, once I start flipping the dice, notice me flipping it. Once I start flipping the dice and recording how many times it lands on the 6, that's experimental. Experimental has to do with experience. I'm actually going to flip the die and figure out how many times it lands a 6. Theoretical, though, is me actually not flipping the die. It's just simply asking myself, okay, what's the number of favorable outcomes on the die that's a 6? 1. So come down. We're going to put probability of a 6. Okay, probability of a 6 is 1, one side. The denominator is 6. The total outcomes, you see the total outcomes of theoretical probability, there's 6 sides to the die, so it's 1 out of 6. Let me turn that into a decimal. 1 divided by 6. 1. Let me clear this.
125.
1 divided by 6 is, I'm going to round to the nearest hundredth. I got 0.1666, so it's going to be 0.17 to the nearest hundredth. So 0.17. That's theoretical. So I'm going to write 0.17. So it's unlikely, but it's possible. It's closer to 0 than it's closer to 1. So that's theoretical. Example 4 now. Let's find the experimental probability. I'm actually going to start flipping the die now, or rolling the die. Right. Find the experimental probability of rolling a 6. Here's what I'm going to do. I'm going to roll it 10 times. I'm going to make a table. Make a table with me. Put a 6 and then put trials. I'm going to figure out how many times I get a 6 out of 10 trials. Say again? So experimental is, the word experimental has the word experience in it. I'm going to roll the dice. Let me bring my dice down here.
I think you probably get like 2 or 3.
Let's see.
0. I probably get 0.
Okay, so first trial. Watch this. I'm gonna roll the die. Trial 1, I didn't get any 6. I didn't get a 6. Here's trial 2 now. Still didn't get a 6. Trial 3. I got a 5. No, it's not a 6 yet. Trial 4. See, I'm actually experiencing, this is experimental. I'm experiencing the rolling of the die and recording the results. So this is trial 4, still no 6. Trial 5, I got a 6. So trial 5, I got 1 6. Notice I'm recording my results by actually doing the thing itself. This is experimental probability versus theoretical. Let's keep going. Trial 6. No 6. Trial 7. No 6. Trial 8. Let's see if Simon's right. He called 2. Let's see if we get it. Trial 9. He might get it. Let's see if he gets it.
I got 0.
All right. So I got 1 out of 10. So the experimental probability for rolling it 10 times, here we go. So probability of a 6 was 1 out of 10 times. Notice the numerator is the number of successes. That's the numerator. That's 1. It's 1 time. The number of trials was 10. It's a different kind of calculation where you're actually doing the thing itself, experimental probability. So 1 divided by 6 on my calculator is going to be 0.10. Just take 1 divided by 10, and you're good to go. All right.
The thing is, what if it lands all of them are 6? Just random, just land it all at 6.
The probabilities are very, very small that would happen, but it's possible. That's my answer to your question. It's possible, but the probabilities are very, very small. And we're going to get into that second hour, what the probabilities are for some situation like that. Go ahead.
So it would be 1.
Well, the experimental would be 1 if it was all 6s. The theoretical probability of that actually occurring, however, is astronomically small. And we'll get into why later. Last example. So we know the difference between theoretical versus experimental. Last example, this is example 5, just for now, before the break. Again, is it in the back side of your paper? Example 5.
You like examples.
How many outcomes are there if you pick 2 marbles from a bag of 5 red marbles and 2 blue?
Can you write that down?
Yes. Last example for before the break. You said I like examples, Soda?
Yeah.
How do you figure? Well, that's what teachers typically do, right? So I could not like them, so they're
We do more examples than those.
Say it again?
We do more examples than the notes.
Oh,
You like examples too, don't you, Soda?
you do more examples.
Don't
than
lie,
the
Soda. You like them. All right, here we go. How many outcomes are there if you pick 2 marbles from a bag of 5 red marbles and 2 blue? So I'm not asking for probability. I'm just asking how many outcomes are there. If on assignment 26, when they ask you how many outcomes, you're going to actually have to draw the sample space. You're going to have to draw a diagram. You're going to have to draw a diagram of sorts, kind of like what I did up here with the flipping of the coin and rolling of the die on example 1. So let's draw the situation. What I'm going to do first is I'm going to draw all my marbles. 5 red, look at 1, 2, 3, 4, 5, and 2 blue. There's the marbles, ladies and gentlemen. You stick your hand in the bag. The bag has 5 red marbles, 2 blue. What are the possible outcomes of you picking 2? What are all the total possible outcomes? Let's see. I'll call this first red marble 1. R2, red marble 2. R3, R4, R5, D2. Blue 1, blue 2. Blue 1, blue 2. There's our bag. 5 marbles, 2 blue. You stick your hand in and grab 2. What are the possible outcomes? Let's list them. Well, if I stick my hand in, I can get the first red marble, look at R1, and I can get the second red marble, R2. That's one possibility. Another possibility is I can stick my hand in there, I get the first red marble, and then get, what's another possibility besides R2? Put RS. R2. R3. Sit on. One of the last example. Stay with me here. So look at, I'm listing the possible outcomes of grabbing 2 marbles. The first possibility would be get the red marble and then get the second red marble. Okay, that's one possibility. Second time, another possibility is to gain the first red marble and then gain the third red marble. Next possibility is gain the red marble and then getting the fifth. How about the fourth? You have something against the fourth red marble? Just kidding. Say again? I'm sorry. Okay. How about look at the, that's the third possibility. The fourth possibility, the first red marble, and then the fifth red marble.
And the other one has to be R2, R3, R3.
Wait. You have something against the blue marbles? How about the first red marble, and then the first blue marble? What else? The first red marble, and then The second blue marble. Someone give Soda a hug there. It's going crazy here. Are those all the possible outcomes?
Yes. Wait, R1, you thought R1. You could get R1 and then R1.
No, you're not putting them back in. Just grab them too.
Oh.
Good point though. You're not putting the marbles back. What's another possibility now?
There is R2.
So you could get the second red marble,
R1.
and then get the first red marble.
R2 and R3.
Right. Now, see, look at R2, R3,
R2.
R2, R4. See, it's the second red marble's turn. So I can get the second red marble in the first, second red marble in the third, second red marble in the fourth, second red marble in the fifth, second red marble blue one, second red marble blue two. It goes on. The question is, how many outcomes would there be?
A lot. So do this. Look. Do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5.
He's saying 49.
42.
He's saying 42. Let's see here. Hold that thought. Let's finish the R2s right now.
There's a lot.
Second red marble. The fifth red marble. Prince. Second red marble. Blue 1. Second red marble. Blue 2.
It 42. Yeah.
It would be 42?
49.
Let's see.
Because 7 times 7, dude.
Right, so look at this. 1, 2, 3, 4, 5, 6. Real quick, look at.
No, look. Now that's it.
Hey, watch the language. Soto. Watch the language, man.
Wait.
No. Have a seat.
Oh.
Watch the language, man. There's 6 outcomes per marble. Okay, and then there's how many marbles? There's 7.
6 times 7, 42.
So it would be 42. Make sense? Why do you think that's cool or not? So notice.
Hey, you know what?
Hold up, Soda, real quick. The next iteration. So I did first red, second red. The next one would be the third red, and then you take all the other second marbles. If you keep doing this, you're going to have you'll have 7 trials, 7 iterations, all the way to the 7th one, and every single iteration is going to have 6 outcomes. You multiply 7 times 6, there's going to be 42 different outcomes. 6 times 7 is 42. So the answer here, 42 outcomes. All right, here we go. If we did the third marble first. So here's the third marble.
Yeah, but here, look. You do R1. Do R1, do R2, do R3.
There's only 6 outcomes for R1.
I know, but why you put the... Bro, there's only 6 outcomes in each one, bro. There's 7 marbles.
Let's relax though. Let's not get angry.
No.
Sucking each other out.
I was just trying to understand.
No, that's cool. That's cool.
I understand.
All right, here's what we're gonna do now.
I apologize.